Hello everyone, welcome to the presentation on paper entitled Unsupervised Hybrid Deep Generative Models for Photovoltaic Synthetic Data Generation. My name is Paras Mandal and I'm the presenting author. My co-authors are Dan Tomonobu Senju and Sukumar Kamlasadan. So as we know, because of advanced metering infrastructure and also increment in energy prosumers, there is a large volume of data getting generated, and because of this scenario, the modeling of solar PV system components has become very complex. And also one of the major issues in power system in terms of data scenario is it's very challenging to access and to get the data available from the distribution level because of the security as well as privacy consideration. So because of this, synthetic data generation has become one of the important research areas at this moment, and highly motivated by these data issues, we propose to generate synthetic power PV power data, which we have proposed in this paper. And we are exploring two types of models, in particular deep generative models. One of them is VAE models, and another one is GAN models, and we combine both of them to develop hybrid model, which is VAE GAN model. And this VAE GAN model is the combination of actually hybrid deep neural network that incorporates LSTM and CNN. In general, the novelty of this paper is that the application of deep generative model has not been thoroughly studied and explored in the context of smart grid time series. This is the proposed methodology, and you can see here how our proposed model VAE GAN or variational autoencoder generative adversarial network is being illustrated. This is the data input flow, and this is the main engine of the VAE with hybrid encoder, and output comes here in this way, and there will be discriminator coming up here, and finally we get the combined models output, that is output coming from VAE and GAN together as shown here. Please note that in our proposed hybrid DGM model we have a consideration of SDNN, which is the combination of LSTM and CNN. This is the output results. We have considered different matrices as shown here: precision, recall, coverage, density, DFT, and MMD. We compared the proposed VAE GAN model with the individual VAE model, and this shows the synthetic data generated, which is in red, versus the green, which is real one, for the solar PV power, solar radiation, and temperature. And we consider all the 4 seasons of the year and develop synthetic data set for PV power, solar radiation, and temperature, as can be seen here in this table. And further results as shown on this slide is about the performance measure deviation of the solar PV power output over the spring season, and you can see here the precision level is around 0.36 up to around 0.63, and you can see for the density is coming in this range, and for the another matrices DFT and MMD has been presented here. So in conclusion, this paper presented the very important two most popular deep generative models, that is VAE and GAN. And our proposed VAE GAN model is the hybrid model, which is the combination of VAE and GAN, and it incorporates SDNN, which also has the feature of CNN and LSTM layers. And we consider the metrics such as precision, recall, density, coverage, DFT, and MMD in order to measure the generalization and the diversity capabilities of the proposed deep generative models, that is VAE GAN, and also individual model VAE, in particular to generate PV data samples. Our future work will be, we can easily apply this DGM model to different downstream tasks such as in microgrid, and other application could be in the area of cybersecurity and also interoperability in the context of smart grid. Thank you very much.